Now, in this question, we're being asked just to make a simple comparison without any real calculations. So obviously, as soon as you make certain recognitions, for instance, what you should recognize is obviously that this is a base, it's an amine group attached to that, and then we look at CH3 and H3Cl. You should recognize that's really similar to something like ammonium chloride, where you've got a cation and anion, and obviously the CH3NH3 plus and the Cl minus, which make up this ionic salt, that the CH3NH3 plus is in fact the conjugate acid. So we're looking at a weak base here for solution A. When we split these two up, we're looking at the Cl minus, which does nothing with water, but the conjugate acid, CH3NH3 plus, is obviously going to create as a weak acid, and that will create an acidic solution. And perhaps the key in the last question is recognizing that when you have a combination of the acid and its conjugate base, and they're the same concentration, that really should make you think of the fact that this is just like a buffer solution, and it is a buffer solution, and therefore the pH is going to be basically the same as the pKa. So we know what the pH will be in that case. So if you can answer that and do some equations to show that you understand that, then you should be able to answer this question properly. Alright, for solution A, when we put that into water, this is the reaction we get. We get a proton coming across here, and we get the conjugate acid, and remembering if we've got a base, you should always expect to see hydroxide ions on the other side. So therefore the pH in this case will be greater than 7, and it will be a basic solution. So if you write that and discuss that, then that should be that part of the question. Now, for the second part, B, we should write an equation showing what happens when we put that into water. And it splits up into the two ions. Cl minus does nothing, so we're not going to write an equation for that. And it's fair enough to write a statement about that as well. You're trying to be thorough in scholarship and addressing all points. And then we're going to show what this ion does with water, which is obviously it you get a proton going from there to there, and we're going to get this excess of hydronium ions, which is going to mean the pH is going to be less than 7. Okay. And perhaps the key to this question for part C is just recognizing that we really are talking about a buffer here, and just recognizing the fact that having these two solutions, and even if they weren't exactly equal concentrations, we'd still have a buffer. And obviously if we had more of the base present, we'd expect the pH to be greater than 10.6. If we had more of the acid present, we'd expect it to be less than 10.6. But as they're equal, we'd expect the pH to be 10.6. Okay, so we can actually do a little proof of this if we want to, and in scholarship I would want to. And that's just, if we cancel that, and we cancel that because they're equal, then the Ka is equal to H3O plus concentration, and therefore the pKa is going to be equal to the pH. Okay, so that's that question answered. Alright, so in this case pH equals 10.6.